Hey, how's it going, everyone? Welcome to the stream. So, an old friend of mine is here, Lisp Gamer. How's it going? So I think I'll start off as I usually do. I'll just do a little summary of what I've got working so far. And you know what? I'll actually explain a little bit what it is I'm working on for you, Lisp Gamer, just so you sort of see what all this is about. Yeah, here, let me catch you up so you don't have to go look at videos or anything. So here's the idea, right? Basically, as you know, I've spent a lot of time writing a Vectrex emulator, and as it turns out, there is actually a fork of GCC, an old GCC, it's like 4.6, that somebody added support for the 6809, so the CPU that the Vectrex uses. The person who did this actually did it for arcade boards, so that people could write games in C and C++ if they want, but mainly C, I think, so that you could compile games for these arcade boards. And of course, since it's the same CPU as the Vectrex, some other people took it, and yeah, no, I know you worked on 6809. So somebody else took it and then put together a small little kind of tool chain and a makefile and stuff, and made it possible to very easily develop games for the Vectrex. What I did is I took that and added the missing support for getting C++ to work, because basically there was a couple of things missing, right? For example, if you have globals or statics that are C++ objects, those constructors have to be run before entering main as part of the init. There's no CRT, so I had to write the bit of the CRT that does that kind of stuff, calling constructors on static initialization. Exactly, no init chain. So I did that bit and got that working, and so basically now it means you can write C++ 03 because it's a GCC 4.6, and I put together an actual Pong game, and it works. I also did a bit of work on sort of generalizing some of the Vectrex functionality, making it easier to write code. Now that's cool, but then ultimately it would be really fun to be able to debug these programs. And this GCC, what it emits, it doesn't emit an ELF, with dwarf information if you pass it -G. Instead, it outputs the executable, which is just like a binary blob. And then for debug symbols, it outputs this text format that you might have heard about. It's called stab or stabs. I don't know if you've ever heard about that. Let me see if I can bring that up. So this thing. So it's this pre-dwarf representation. It's pretty old. I think it dates back to the 70s for really early days of creating debug info. So it even predates GCC. And I think when GCC was created, stabs was one of the first debug formats that was added to it. So what it is basically when you compile, you generate these listing files, and if you enable -G, it intersperses in the listing this information. It's all textual, you can see it here. So I have a main program here, and then on the right side you have the listing. And everywhere in this listing you can see spread out there is these .stab lines. And then this, it has a format, and you have to basically parse this out and extract information, debug information from here. So what I've done is I have a parser for this. I parse this out, I collect information, and I build my own debug information. Yeah, so there you go. So you understand the general gist of it, right? So I do that, and then the other bit is actually implementing a debugger. Now for that, I'm making use of, sorry. For that, I'm making use of this really cool, so I can find it here. So yeah, this specification that Microsoft put together, it's called the Debug Adapter Protocol, or DAP for short. And yeah, I think this picture sort of explains the idea behind it. So this is like the typical scenario without DAP. So the idea that you have like all these separate IDEs, editors, and other tools, and everyone pretty much has to write their own debugger in there. Let's say an IDE and an editor that are two separate tools, both can debug this stuff. Yeah, GDB has something similar, but like it's in GDB as opposed to being outside. So you'll see what I mean. So basically, you know, traditionally, classically, this is what you'd have to do, right? You'd use an IDE and it would have its own implementation of a debugger for Node.js and for Python. And you can see there's a Python debugger here and one here, and then these two are separate implementations. And basically, what they've done is they said, well, why don't we do this other thing where we have a protocol that's generic for debuggers. Everyone who implements it can speak DAP, and then DAP, there's going to be adapters implemented for each, let's say, target environment, right? Language environment. So, you know, if there's an adapter for Node, then any one of these who speak DAP can now debug Node, right? And similarly, if you can speak DAP, you can also debug Python and C# as long as there's adapters for it. So that's the whole idea, and this is pretty much what VS Code uses. It also is what Visual Studio supports, and Emacs, Vim, and other tools now have support. I think we can see, oh here, implementations. Oh no, so those are the actual adapters. Who are the ones again supporting tools? Here we go. So here you get an idea. So you can see here VS Code, Visual Studio. So the protocol is, it looks a lot like, I guess you'd say like a REST API, like an HTTP kind of thing. You know, requests and responses. So something like this. So you see it's just a bunch of messages. So I don't know, I haven't written a language plugin for Visual Studio Code or anything, but it's probably very similar. So basically you have just a bunch of these like requests and responses, and you have events and stuff that you can send. Now, to make my life easier, in fact, one of my colleagues at work, he implemented a thing, I don't know if it's in here, DAP. I think it's in implementations. Nope. I thought it was in here. Anyway, it's somewhere on this page, but basically there's this library called CPP-DAP. CPP-DAP. So it's here. It's on the Google repository. This guy Ben Clayton, he's a colleague of mine, so he implemented this, and that's sort of where I got the idea. I was like, hey, you know what? I could use this thing to do a proper debugger. So what it does is it basically wraps the protocol and makes it easy to implement in C++. So you can see here, it's a library or SDK implementation of the Debug Adapter Protocol, providing an API for implementing DAP client or server. So what I did is let's say you write your C++ program for Vectrex, and when you in VS Code anyway, you can say, I want to launch to launch this Vectrex C debugger. And what that does is I have it configured here to launch my emulator with a specific argument -dap that puts it into this mode, and it launches the emulator, and it actually speaks through stood in, stood out. And what my emulator does is it says, okay, let's load up the this ROM here that you're telling me that you want to debug, and the emulator basically looks for inside the folder here, and all the stuff will be configurable. But right now I go and I start looking for all those listings, those files there, like the RST files here, and I start parsing them. I extract all the debug info, start running the ROM, and I'm also listening for events through the debug adapter. So, you know, if you set breakpoints, I'll get a message with all the breakpoints. I store that information, and as I execute instructions, I'm looking for if we hit a breakpoint, if you do stepping, step in, step out, all that stuff. So I can actually give you a little demo of what that looks like. Let me choose a better example because this is what I'm working on right now. But let's say we go to like, these are just all examples of little things I've been working on. So let's see, find one that's interesting. I suppose this one's pretty interesting. This is when I was working on pointers and references, stuff like that. So yeah, so let's build this. So the Vectrex Display, so the actual emulator opens up as a separate window. So as you step, and it'll actually render in there. Of course, if you stop, it'll go to black. I have to add, it's on my to-do list to have it so that it doesn't actually clear the display. You know, like it'll stay in a paused state and keep the display there until a certain thing happens. But yeah, it's pretty much what I did. I already have a kind of like command line debugger, right, for my emulator, and I did that kind of thing in there, so I'll just have to do the same thing for this one. So this is built. So if I hit F5, see, this is the emulator. I have this little thing to attach for development purposes. So you can see now that, you know, this is black here. We're here on the first line of main. You can see there are no variables here. There's a call stack. So actually it shows here on the call stack that we started at F000, which is the, you know, in the vector table, this is where the address of the main function is placed. So technically we start from there and we jump to main. Then from here I can F11, yeah, exactly. From F11 I can go in here into foo. You can see now that foo is on the call stack here, and you can see a whole bunch of local variables. And you can see that there's a whole bunch of local variables and they all have junk in them. So one thing I want to do is I want to track which variables have actually been modified before I display them, sort of like the autos thing, or at least show them with a unset value. But these are the values that are really there, like at that offset on the stack. And, you know, let's say here I'll set 4 into A, and you'll see it just changed to 4 over here. P here is now going to change the address of A, and then I'm going to write through the pointer and it changes this to 5. So this is me basically having fun with implementing pointers and references. So you can see here they all end up pretty much with the same address. This is a pointer to pointer, and I write through that, a pointer to pointer to pointer. I also have here the support for expanding. Let's say here the triple pointer gets expanded to star PPP to star star, and then triple star, and then we get back our value here. And then that writes 13 there. This is a reference to a triple pointer, which pretty much gives us, right now I just treat references like pointers. Thank you. Pretty happy with this. And then here we can basically recurse. I wanted to do the recursion thing here because I wanted to make sure that if I click on, let's say, the call stack here, this entry, that I correctly display the values from that call stack iteration. And then if I go into this next one, it's all different, you see. And then here, of course, as I go through, all this stuff changes. And this all works, you know. So right now A is 6. Because we set it over here, but on the parent call stack it's 14. You can also see that the pointer addresses here are getting smaller because we're adding more and more to the stack. Like if I go into third time here, and let's go all the way through. Like if we focus on, let's say P, the very first time it's CB DD, then it's CB CB, so DD to CB to B9. So you can see that the values are getting smaller as expected because the stack grows, you know, by getting smaller, the values, right? It grows in the by subtracting. Yeah, I don't know when to say up or down. Depends how you look at memory, right? Everyone has their own, you know, it's either you think of it growing down or you think of it growing up. You know what I mean? Like actually for me, it's up. Because I think of it like, you know, the zero is at the top and then it goes downwards this way in my mind. I think of memory downwards, and so I think of it going upwards. Oh yeah? Oh, that's interesting. So anyway, so that's pretty much what I've been working on, and you know, very quickly, like this is what it looks like to sort of implement the debug adapter protocol. So it's really nice. It's a very nice library. It's basically done on as a callback system. So you create this session and then you register a whole bunch of callbacks. So you register handlers, and it uses you know, like overload resolution to figure out which handler you want to register. So for example, here's a handler for the initialize request, and here's one for the threads request and stack trace request. You can see like, and for each one of these, the goal is you get this request, you can inspect it, and then you're supposed to return, and there's an expected return value for each one of these. So here it's expecting a response that is a stack trace response. So my goal here is to look at the request and then to return a response of that type. So it makes it really nice and easy to implement in C++. Some of the tricky bits of implementing a debugger like this was doing the kind of like this step in, step out, and step over is a lot more complicated when you're doing instruction level debugging. Sorry, like not instruction, I should say source level debugging as opposed to instruction level, because you know, stepping is kind of easy when all you got to do is step one instruction. But when a line of code represents like a set of instructions, you have to figure out how many instructions to move forward, to do the step over, to step into, and all that, you know. So that to do that, I had to implement effectively a state machine in here. So I have like the state machine of like I'm running, I'm pausing, I'm stepping into, step over or out, finish to step out. There's some stuff there, and just tracking like, you know, all the logic for doing that correctly was rather tricky actually. Yeah, it's pretty clean. So I got all that done. So you can sort of see like basically this simple example here. I just kind of go through and you can see the sort of progression where I started off with simple ints and some scopes. Then I added support for floats, doubles, chars, like all the different primitive types here. This was working with pointers and references. I implemented those. Then I worked on enums and bools, which are pretty much the same thing as far as the debug info is concerned. And now what I'm working on is structs, is implementing structs and classes and unions, basically structured data types. So that's where I'm at right now. So right here, all this here. So I've got this enum here. I've got oh yes, I was messing around with forward declares as well, which Yeah, it does support floats, actually. I mean, it emulates floats, right? As you can imagine. Actually, I say it supports floats. I mean, the compiler generates code for it. However, if I start doing any kind of like arithmetic on floats, anything that it has to generate at runtime, it actually fails because the compiler is looking for implementations of certain functions. You know what I mean? Like it's looking for, from the CRT, an implementation of a function to add to floats, for instance. So saying it supports it, unless I implement that functionality, then the answer is no, not really, you know. But if you do, it will store floats. It'll store them in the right format, you know, in the IEEE whatever format. Right, exactly. The runtime has no support for it yet. And it's possible, I know that there is an implementation of a runtime for the Vectrex out there for people who write in C that I might take a look at and see if I can steal that. But yeah. But the compiler will, at least if you do like, you know, if you do anything at compile time with floats, it'll correctly emit the code to store them and to load them. But yeah, you can't do any math with it, so it's not super useful. At least with what I have. Yeah, probably. But I think for the Vectrex, floats is not really a good thing to use just because it's so extremely limited in terms of memory. Like literally you have, and I have it here in my make file, you have about 618 bytes of RAM to play with. Now obviously you have a lot of, you know, you have a ROM. You can have like, I think it's, with bank switching you can have as much as you want, but you have about 32K of ROM you can just play with. So if you pre-compute everything, you can have all that in ROM, and that's pretty good. But for actual like RAM, you don't even have a K. You literally have about 618 bytes available to you. Yeah, it is an 8-bit machine, exactly. So all that to say is I don't think I have to work too hard to get, you know, float. I don't think I need to get float support in there. Most likely some fixed point library might be good enough. That might be something I'll work on, writing like a little fixed point C++ library, you know, with templates and stuff. All the people who write for the Vectrex use C, so they're not used to that kind of thing. They probably use like some macro-based, you know, fixed point library. But I think it would be nice to have some compile time, you know, compile time errors when you do things wrong, or have it adapt correctly for different fixed point sizes. Okay, so what I'm supposed to work on now. So what I've been working on since last stream, which was last Tuesday, was the structure stuff. So let me just refresh my memory a bit here. Right, so I added the struct type. Basically it's a vector of members where members have names, an offset in bits, size in bits, and then the type of the member. Right. And I have another type of offset that I added here for my variables. So if the variable is itself a struct, is that correct? Why am I doing this in variables? I don't even remember. Let me see. That's what happens when you don't look at your code for a week. Yeah, so I put this here. Anyway, it'll come to me. And then here is my code that I was working on for parsing out the struct information. Here. So basically I create this, I parse out each member of the struct, and then I create the struct type here. Oh yeah, okay, so that's cool. Yeah, and I remember there was a whole bunch of, as I was doing this, I was doing some tests and I ran into a whole bunch of things that I will have to do for structs and classes, which are here. But I won't do them yet. I'll kind of get the basics working and then iterate on that. So here is add support for pointers. So I learned last stream that when I put a pointer in a struct, like for variables, because pointers are weird, they are not predefined. I mean, they're not weird, they make sense, but basically a pointer is a pointer to some type, and what happens is that I have to create, and in my case, a type for the pointer. So, although I have been wondering whether I need to do that more and more, just like how just how they don't bother creating a type for every pointer out there because it's just a pointer to a type. I might want to do something similar. So I may change my strategy for that, but we'll see. Also, bit fields. To be able to support bit fields, I need to change some stuff where I'm currently storing byte offsets, but I'd have to store bit offsets. Yeah, support for vtables. That's going to come when I do classes with virtual functions. I'm going to have to add some magic, I think, for yes, like when you're debugging inside a member function, you know, being able to display the implicit this pointer. So if there are members that are part of the class that you're, like part of the class of the member function, I would need to detect that or know that that's the case, and because of the whole implicit this, and then be able to display those. So we'll see how that looks. And also there's the whole support for self-referential types. So that's not just a pointer, but a pointer or reference to yourself. So like doing the linked list type of thing, which I do think is related to supporting forward declarations. So forward declarations add a little bit of complication because it's not like the debug info actually makes sure to define all types before they're referenced. So it'll do just like C++ does. It'll say, oh, look, here's a pointer to some type. I don't know what this type is. And then later on, that type will be defined. So I'll have to do the same. But all of these are things I'll do incrementally. So right now I'm sort of staying within the simple case. I want to just have like a basic struct here that's got like different data types, nothing too complicated. And yeah, just focusing on that here. So let's say I remove this and remove this. So we just have foo. We have this enum here, that's fine. And we create one and we just set a couple of variables. So if I could just display this and display all its, expand it and display all its properties, that'll already be pretty cool. So I actually think that with the code I have right now, it should already be able to at least get the type for foo. So let's see what happens here if I debug and wait for attach. And then before I attach, let me put a breakpoint here, I think. Yeah. Oh, here we are. That was fast. Okay, so let me see. Okay, so here are my debug symbols, and all right, hit F5 again. So we go types. I have 21 types right now. So in here I should see a type for my struct. Okay, not easy to see here. Why is my byte size so out of whack here? I think it's because it's optimized. Let me just try my debug build for a second. Okay, that's better. That was to be a question. Something then the optimizer can even intermix code from different lines. I'm sorry, I don't know what you're saying. Wish it would show the type right away. So I have primitive types here. One of these types is going to be a struct type, probably the last one. Let me try from the bottom. Enum, primitive. Oh, where's my struct type? So the debug information when you're stepping source line by line. Oh, you're saying with optimizations enabled? Yeah, I haven't. I haven't even tried with that, but it's in my list of things to do. Is make sure that it behaves somewhat okay with optimizations enabled. But I think it'll be okay. Because the way I wrote my debugger is like the stepping logic is I'm basically doing my best to match the current instruction to a known source location. And once I've hooked onto a source location, I sort of latch onto that, and then like once the next instruction is no longer part of that, I have a whole bunch of logic that's like, okay, we're no longer at that source location, and then depending on if you're stepping over, stepping out, stepping into, what does that mean? Yeah, so that's where all the state machine stuff. But I'm basically, because I'm doing my best to latch on to a source location given the current instruction, if I get to an instruction that doesn't have a source location or the source location changes, it should behave correctly. But we may get the whole like jumping around the way we do when you're stepping through optimized code. Yeah, so I did not hit this struct symbol, struct definition, which is odd. Why is that? Okay, foo, empty foo.rst. Oh, that's the wrong file. Oh, there we go. All right, because there's 3 files. Okay, that looks good. So there we go. So now I should have, yeah, there we go. A bunch of types and variables and all that. This makes way more sense. So here we go. The last type that got added to my my vector of types is this one here, which is a struct type named foo. Why do I have name twice here? Okay, it's the same thing as this one. Okay, and then it's got 5 members: A, B, C, D, E. You can see here that you can see like the offset bits, so and the size. So like the first one, A, which corresponds to, we've got a float, a bool. So the float offset 0, the size is 32. B is at offset 32, and its size is 8 bits. Then you got C at offset 40, 16 bits, so that's our enum here. And the reason why it's 16 bits is because I have this value here, this negative 5,000. No, I know. For optimized builds, I'm not expected to get it right, but I expected to do something, you know, something useful, right? As useful as possible. We all know that different debuggers, some debuggers handle optimized builds better than others, right? Like I remember the days of Visual Studio, its debugger basically lying to you in terms of what values you would see in a variable, which was terrible. So you would never know if the values you were seeing for variables were correct or not. And then at one point they finally like changed all of that in their debugger, and like now it's not like that anymore. Now if it can't show it to you, it'll actually say this value cannot be shown because it's been optimized out. But if it can show it, and it does a pretty good job of doing so, like it knows which registers are being used for certain scopes to represent a value of variable, it'll actually show it to you in your debugger when you hover over your variable. It'll actually look at what's in the register, which is pretty awesome. So that's some pretty advanced debugging stuff. Not sure I'll be able to get to that point, but we'll see. As long as it's fun to work on. So at 56, then here we have, this is the bit field thing, where I have these two bit fields here, 6 bits and 2 bits here. Yeah, so that's going to be kind of tricky to display. Well, I mean, anyways, should be okay. I have everything in place there, I think, to get that working. Okay, so that's good. So now that I have that, the next thing is to make sure that I'm parsing the variables of that type. So let me see if I picked up on that here. I might have actually picked up on that. I think I did, yeah. So I have source, no, what is it? So I have the types. Ah, that's cool. So you wrote your own remote debugger. Did you, like, was it from scratch, or did you get like take advantage of any existing like debugging tooling? Ah, that's cool. So initially, and you were mentioning about GDB earlier, initially what I wanted to do, which would have been a lot simpler, was to take advantage of the GDB, what's it called there? They have their own like debug protocol, the GDB stub, and I actually started working on it until I realized that the whole GDB stub thing totally depends on dwarf. You have to have an ELF with dwarf information, or at least dwarf symbols available for GDB to load. It doesn't know anything about stabs information. It's not going to parse these RST files. So, unless someone writes a stabs to dwarf tool, which is possible, right? I mean, in the end, dwarf is basically a bunch of symbol tables. But without that kind of conversion, there's no luck in using the GDB stub thing. So I had to abandon that. That would have allowed me to use quite a few tools, because a lot of tools know the GDB stub. In fact, VS Code has an adapter for it, so that would have worked. But then when I realized I could use this other protocol, now this protocol is the GDB stub thing actually does most of the hard work for you. It's really doing the heavy lifting in GDB, since it is the debugger, right? And all you got to do is kind of display things. And in this case, I have a lot more heavy lifting to do myself because I am writing the debugger. So that's the downside. The upshot, though, is technically this would be supported by more tools. And I guess it's also another upshot to this is technically it's not tied to GDB, right? So if there ever was another compiler, which there won't be, but if ever someone made, I don't know, another compiler compile for the Vectrex, then as long as it could generate stabs info, then we would be okay. Oh, really? That's kind of cool. I guess this developer was inspired by your own work. Like you're talking about the remote debugger, the one from Visual Studio, that one? So what am I looking for here? Oh yeah, scopes. Okay, right. Yeah, I know that GDB stub is often implemented in hardware for embedded systems. Right. I have to say, like, it's been really a lot of fun working on this debugger, and it gives me a deep appreciation for what debuggers can do. You know what I mean? Like what they must do. It's a lot of work. And like I find Visual Studio is an amazing debugger, and like just now what I'm doing here, expanding all these types, like this is awesome, right? And yeah, it's not trivial. Yeah, the language server is pretty interesting for sure. That's another protocol that, or another specification, I should say, not a protocol, a spec that Microsoft put together, language servers. Been really helpful in a similar way, right? For like multiple text editors and IDEs to be able to speak to a language server for a given language, giving them all the information, the type info and all that. And I think the idea there is that it's also generic, right? Most languages have the same things to represent, autocomplete and scopes and all kinds of stuff. Go to definition. Okay, so I can see clearly here that my scope, so this is the scope for the main function. The one scope has a variable which is of type foo. So I can see it here. It's called f, which is f here. So all I gotta do is start implementing the code to display this. Now, let me see. Type. Yeah. And then I can use my offsets to display those things. Yeah. They're cool, but when you've worked in places where your code ran in another memory space and the only way you can look at what's happening is 32 bytes that you can scroll across the other address space, you learn how to read the source and figure out what's broken before you jump in the debugger. Yeah, for sure. There's that whole thing about debuggers becoming a crutch, that if you use debuggers, like if you rely on your debugger too much, you actually stop thinking and stop actually like looking at the code and figuring it out with static analysis. So many times it's important to just stop and look at the code and think and then go like, what's going on here before you start looking at what happens. So I think it's like a healthy mix. You got to go for the healthy mix. I probably rely a bit too much on my debugger. You get lazy like that, right? It really is a crutch. Probably why I'm writing a debugger for the Vectrex. I'm sure everyone who's writing Vectrex games is like, I don't need a debugger for this. It's so simple. It's probably true. But for me, it's not really like, oh, I got to make this killer debugger so that the whole world can use it. Probably I'm the only person who's going to use it. But it's mainly because it's fun. I'm just learning, and what else am I going to write a debugger for, right? I have this Vectrex emulator, and I thought, yeah, we can compile C and C++ for it. Why not write something that can debug for it? But yeah, it's just like sometimes printf debugging is a better tool. So you gotta not forget to think. Right. Yeah. You can confuse your debugger. So yeah, I'm gonna fall into this piece of code and I'm gonna call create dap variable. We're gonna come in here, and in my case, it's not a primitive type,
and it's not an enum type, it's going to be a structure type. That's basically what I have to deal with here. Oh, hey, Bama. How you doing? Hey, all right, Lisp Gamer, I guess you're taking off. Well, thanks for chatting. I'm glad I was able to show you what I've been working on. All right, so basically we're going to have something very similar. This time it's going to be for a struct type here. Now, similar to what we were doing, I think it's going to be closer to the way we handle indirects here. So get the value of the pointed to address, so that's not what we're going to do here. Oh, so you're saying hi to Bama, sorry. So we'll start with displaying the display of value here. I guess I don't need to actually put the name here. So what I gotta do, I have to create child variables to display each member. So that's what I'm saying. It's kind of similar to what we do for pointers and references. For each of the members, we're going to want to create a one of these things. Yeah, and I'm going to probably, I guess I'll store the absolute address. I don't know. Or maybe I'll store an offset. That's the thing, though. I think I might have to do absolute address here. But then I can't quite, yeah. No, we'll see. So something along these lines. Let me think about this. So the name will be that of the member, and the type will be, oops, like that. What's this that you sent? Oh, someone built something. Yeah, so if I come back here, the thing is, so here I'm saying struct offset, but what I really need is probably an absolute address as well as the offset and the size. Unless, yeah, that's the thing. Remember, that's the thing. Variables have no knowledge of the encompassing type, so I'm going to have to store the absolute address in here. And then from the type, I should be able to get the info that I need. So yeah, I think this is not quite correct. Yeah, I think all I gotta do is store
just the absolute address for each member, and then from that I can then use the types offset and size to do what I need to do, I think. Yeah, so pretty much the same thing here. Of course your cat game has a lisp. I'm not surprised. Yeah, so I think for the display value for now, we're not going to put anything. Although I guess I suppose I could display at least the address of it. Maybe that's useful. To do display first few members, something like that. Obviously display type is going to be display type, display value, yeah. So, oh sorry, I shouldn't call this indirect type. Like that. Yeah, it looks like it's pretty much the same thing as an indirect type, except for the fact that we have multiple members. And I won't be able to reuse this code as I have here, because I'll have to create multiple variables, I think. Let me see here. Yeah. Right, this function I wrote only creates a single variable. Okay, so I'll need to change this to return multiple variables, and then we can push them back here. Or at least maybe just have it populate this to immediately. We'll see here. Oh, it's just a std vector. Okay. All right, so we changed this to be returning multiple variables. We have a bit of changes to make in here, but should not be a problem. But ultimately, if we do that, then all this code here, now this is the only part that's a bit annoying. I hate that there's no easy way to insert a bunch of vector variables at the end of a vector. Like basically I'd have to do this. Maybe I'll just write a little, I know I have some helpers for this kind of thing. What did I call it? No, I have not made one. But I can add one. Let me put it in the other file. I shouldn't be putting these in here. What was it called? You know what? I'll move it after. Maybe I'll call it container append, because I think they all work this way. As long as you have a pushback, it should work. In fact, it would be good if I could move the values. Yeah, there's no like move from, I think I'm going to have to do it with a loop. That's what it means. Something like that. Something like this. Okay, now I gotta change this code so that it can return a vector. So I won't be able to do this here. Instead, what we'll do we'll have a result vector like this. We will have a function actually do this. Display type. Next will be a enum type. This guy here, same deal. Pretty much all of them have the same thing for display type actually. Anyway, and display value here, so I guess I'll move that down there. Yeah, Lisp Gamer, that would be great. We'll chat soon. Thanks for hanging out, man. You too. So actually what I'll do then is I'll move this down here for some symmetry. In fact, I don't really need a variable for it, do I? May as well just do this. Same here. Get all this code cleaned up. For structs, we're in the middle of doing that. Let me just get this guy here correct. So what do we got? Display value. All right. Like that. And display type. So this I guess I don't need either. So we'll put it like that. And then variables reference will go there. Very good. And now we can actually do this bit in here. Yeah, like this. Okay. Let's see if this compiles. Lots of changes there. Okay, so let's see. True. Probably delete that. Yes, that's true. Don't have a value address here. Yeah, and this should be an integer. This will have to be an int. My display type is unnecessary. Yeah. Now value address is going to be the value of the pointed to address. Now, right. So in my case, we're talking about the address of the struct itself. It's not really the value address, I suppose, is it? Yeah, I guess it is. Get value. Wait. No, that's right. I don't need this. I just need the variable address. Right? In the case of the struct, I have the address of the variable. I just need that plus all its offsets. Yeah, that's correct. Let me see here. Does this make sense? Yes, it does. Yes, it does. So what I do is I just put the var address here in, where is it? Location. Okay, so we'll say the struct address is used to as the base address for each member. All right, so let's say I have this now, but the problem now is that even though I've added all these types, and these types, yeah, I'm missing something here.
Yeah, this is not gonna work. Because let's say the member is an integer. Sure, I've stored the address. What I don't have... No, I need to add the offset to the address. What I'm missing is going to be basically things like the size in bits for what am I trying to say here? For bit fields. Yeah. So okay, so basically let's rework this a bit. We have to compute our address as the variable address plus the offset of this member. M dot offset in bits. I'll divide that by 8 because right now this is expected to be in bytes, right? Yeah. Whoops. Yeah, it's the byte offset. Now this will not work for bit fields. I mean, if I wanted to make it work for bit fields, I guess what I would have to do is change my, like I was trying to do here. This is where, okay, now it's all coming to me. This is why I was doing this thing with the struct offset. But maybe what I would really need to do is make it so that a variable can have a bit offset. So like a base address, maybe that's what I need, like a not absolute address, but more like base offset, you know, base address plus an offset in bits. I think that's what I would need. What I called struct offset is not quite right. I need to know a base address and then the offset and the size, I suppose. Although the size might, the size will be important for types like integers. So if the size is specified, it's some kind of subset of the type. So I'm thinking something along the lines of base relative address. Yeah, let me just actually code it up and just see what it looks like. Whoops, right here. Optional if set read this many bits of value of size specified by type. Or bit fields. I mean, that's pretty much the only use case I can think of. Because pretty much everything else has byte sizes, right? So it's really only bit fields that have this kind of weirdness. Yeah. Maybe arrays? No. Yeah, I think that's it. So it looks something like this, I guess.
Okay, so we'll do that later. Right now what I have is enough for non-bit fields to work correctly, I think, if I did this right. Probably a bug somewhere in here, like there's probably some problems with container move append. Yeah. Conversion from size t to t requires a narrowing conversion, right? Because this wants a uint 16t. So for now, store struct address plus byte offset to each member. What's the problem here? This takes a size t. Oh, it's because of the 8. Oh, that's annoying. Really? Conversion from int to t. So where's my int? So uint 16t. Now that's a size t, so that's not my int. And then this is an unsigned int. Where is my int in here? I'm not seeing it. Oh, no, offset bits is size t. Yeah, so what's the deal here? Okay, let me just try this. Oh, see, it's not working. What am I missing here? What's element 1? Is it? Oh, it's the result of this addition? Could it be? Ah, that's weird. Why is C++ so weird? Okay, I probably just need to do this. Not quite like that, like that. Let me see. I'm not seeing it. Let's do it piecewise and see what's going on here. So if I say uint 16t, Okay, so conversion from size t to unt, so that's expected. Huh. So that totally works. Now if I do it this way, I'm guessing it's going to work fine. So this has something to do, oh, I think I know what this is. Okay. Right. It's because I'm using braced initialization. It does not allow narrowing conversions. And I'm trying to create a absolute address, which is a strong type. That's it. And then the strong type here has it's a strong type of uint_t. So it doesn't want to do a narrowing conversion there. So probably what it means is I would need a static cast on the outside of the entire expression for this to work. So if I want to go back here, I think I'm going to leave it like this anyway, but to make this work, I'd need yet another static cast on the outside of the entire expression. Otherwise, it doesn't allow the narrowing conversion. So just to see that I'm right, if we do this like that, this should work. And it does. And I could probably remove this internal cast, but maybe not. We'll see. Oh yeah, that works. But having said that, I kind of prefer having it anyway as two separate things, because we're giving it a name. We're saying this is the member address. Okay, so let's see what this gets us. This should actually display the members correctly, except for the bit fields, which I'm not even setting anyway in my example, but okay, let's just see what this looks like. Oops. All right, so there's F, and it did not expand. So not quite there yet. Let me actually see if I broke anything with my changes, because I made quite a few changes there. So if we comment this out and just go back to, say, my pointer example. Wait. Okay, so all the locals are there. Okay, so this looks like it's all working as before. So that's good. All right, so let's go back to the bottom here. Great. This time we will attach. What I want to see now is, do we get inside here and what that looks like. So I'm not hitting my type. Why is that? var.type. Wait, what's this? Source code is different. Oh. What? Did it not build correctly? Oh, because I'm building the debug version. Okay, all right, that makes sense. Right, I switched to debug earlier. So let's go back to our release build. Build that. Hit F5, and let's just go for it. So now we still don't see anything. All right, so at least the breakpoints are there. Okay, I don't really care for the enum type. I want the struct type. Okay, so that's my step function. Okay, so here we go. So I've hit the struct type. I've got 5 members. What are we doing here? Create a variable, set its name and type. We grab our, we compute a member address here. Set its location. We create a dynamic variable. No display value and a variable reference. We call this function. Oh, right. How did this... How come it... Okay, no, it wasn't working. It's because I had not compiled release. Okay. Right. You know what? Okay, let's try again. All right. So I only see the value of A and not of my other members. Okay, so let's debug that again. Let's see what's going on here. Okay, so we finish here. So our dap vars is 5. It's 5 values. Name of F. Wait, I think I got that wrong. It should not say F. Yeah, that shouldn't say F. Oh no, actually it should say F. It's the expansion of F's members. Why did it... What am I doing here? Oh, I see. Right. Huh. That's not how this works. Basically, for my member foo, I only can add one variable's reference for it. And the idea is that the child reference is one that would expand to multiple values, I think. I think that's how that works. Because this is the first time I expand something and have more than one value, so I think that's why it didn't click for me. Yeah. So actually all these changes I made to have multiple variables, it's not what we want to do here. So let me see, how would this work? So let's see. Right. So when it gets, so the idea is that it's going to get a request for that expansion, and then in that request I need to add the multiple variables. So I'm almost there. I just need one extra indirect step, I think. So like basically when it's a struct, let me think, how do I do this? It's a bit weird. Just like how here we create a single variable to display the dereferenced value, we need to do something similar. We want to create a single child that says this is the values of this struct up here. But then only when that gets expanded do we lazily evaluate. Like right now I'm actually trying to create all the members right away, but those may not get expanded, so this is actually wasteful, which is why it's done this way. So I do need to store information.
I didn't get that. Try tapping above to edit.
What a freak me out. Thanks, Siri. Freaked me out there. All right. Yeah, so what I was saying is I need to add, what am I going to add here? Yeah. So weird. I guess I think I might have triggered it with my finger, or I might have said something like "Hey Siri," that sounded like "Hey Siri." Yeah, this is what sucks about this, is because I have the information here about the struct type. I suppose I would have to store the reference to the struct type itself, and then when we expand the child variable, then we can go and do all this that I'm doing here. Right. So I have to, yeah, very similar to how I did. I wonder if I could just extend this child variable, because it's very, like I said, it's very similar to basically any type that can get expanded. So maybe what I'm calling child variable is going to have to be named something else. But then the problem is that right now I'm assuming that a child variable stores the location here as an absolute address. And I guess that's it. I will not store it as an absolute address. I would store it as some kind of struct type. Let me think. Right, and then I would look that up. I see. I suppose, yeah, this is sort of bringing into question my strategy, even for indirect types. Maybe I need to change my strategy here. Because what I did here is I created this concept of dynamic variables. Because I was assuming that the expansion would add a single variable. But really, what I should be doing, I think, given that I have all this information here, let me see. I'm not sure. I'm really not sure what the right strategy is. Like for a pointer, or reference, what I have at this point, so I'm creating the variable, say for a pointer p. I'm saying it's going to have a child. I actually immediately create the expanded child sort of here. And then the idea is that later on, if I look for child variable, whoops. Then later on, when I get the next, let's say we expanded, we're going to get another variable request. If I see that the variable ref is a child variable, I already know I created that variable, so I just grab it And then what do I do here? Then I create a DAP variable off of it. So what was that idea? So maybe what I need to do is create that's it. I create a DAP variable, and then that's the thing. Oh yeah, that's right. And then at this point, the type is the expanded type here. And then, but see, in the case of a struct, I don't have a single variable. I will have a single thing that represents an expansion of multiple variables. That's why this doesn't really work. So I'm trying to think, like, maybe there's a better approach here, a more generalized approach where I don't immediately create the variable. I delay the creation of the variable. So then I'm thinking, okay, if I did that, what is it that I need to store in order to do that? So let's say I think about pointer types. So obviously everything I put in this variable is what I'm going to need, right? So I'll need its name, obviously. But maybe I can derive all this again, that's what I'm thinking, from the original variable that came in, if I can just hold on to it. I'm not sure. I need to think about this. Because on the one hand, it's kind of nice that I have this information here and I can immediately create the child variable. On the other hand, I'm sort of wasting time here creating a variable that may or may not be expanded. Like if it's not expanded, then I created this for nothing. That is true. So let's say we have a pointer type. I know I'm creating the DAP variable for it, and I'm immediately creating a child value, a variable, I mean, to display the dereferenced value. One thing I still don't understand though is why is it that I don't see all of these added in the wrong place then for what I'm doing? Oh, right, it's because of the variable's reference, I think. Is that right? Wait. Oh wait a minute. Maybe it's because I need to first create a variable for this member itself. No, that already exists, right? Yeah. I'm getting confused here. What's going on? I've got the scope and I'm getting the f variable. I'm saying create a dap variable for that guy. Let me actually debug it, because I think it's going to become a bit more clear to me. I think I'm getting tired. Okay. Okay, so we're in the middle of our variables here. This is f, and it's saying create a dap variable for f. So we come through and we find out it is a struct type. So what I should be doing here is creating simply one. Yeah, I shouldn't be doing this, I think. Oh. But I end up creating a whole bunch of these. Name foo, display value is nothing. Oh, okay, right. This also explains why. It's because I'm grabbing the variable name f all the time here. That's not right. Right, okay. So that's why they're all named f. And then when I expand it, it gets one called A. Okay, well that sort of explains then what I was seeing here. So if I were instead to say don't capture var, now here it would make more sense if we were to put the m.name, and this won't be correct, of course, but yeah. This comes back to what I was saying. It's not like you can add multiple child variables. You can only add a single ID, and then from that, if it gets expanded, then you. I mean, I suppose I could create all the variables and then have a way to retrieve them if we get requested. But I think that's just, like I was saying, it's sort of the wrong strategy. It's what I'm doing for pointers, but I should instead lazily create variables if the user desires them. That would be a better approach. Yeah, see? So now I'm getting see, like this is what I mean. So now what ended up happening is I did parse f as a struct, but I ended up adding 5 variables which are the members of that struct. And each one sort of has an expansion of itself. This is all wrong. And the reason why it was before I had f with a single a is because I did create all variables with the same name, so it saw the f and it only took the first one to display and ignored all the other ones, probably because I had the same name. And the first one's child was a. So this explains why it's behaving this way, but it does not tell me what the right strategy is here, and I think I'm going to have to change this. I already have this thing called dynamic variables because I was creating them temporarily and then retrieving them later, but I'm going to have to probably go for another strategy here. Like if I were to keep this, what I would have to do is, you know, make variable probably like a type that can have children, and then, you know, I'd have like I'd add child variables, and then when we'd expand the child, we grab this parent variable and then say, oh look, it has multiple children, and go through and add all of those. Something like that. That could be one solution, but again, I don't think it's the right one. Instead, I need a way, when you expand, I need some kind of identifier that says, with this, you can go and create these variables. So I like I was saying before, I need to store the information that I have here required to do this expansion. Okay, you know what? I'm going to stop here. I'm going to think a little bit about how I want to rework this, and Thursday, when I stream again, I'll tackle this rework that I need to do. Because I'm also thinking, like, I can't do it this way, because if I have a struct, you know, that contains a struct that contains a struct, I don't want to go and be just creating all those variables. This just doesn't make sense. It makes more sense to have this lazy expansion thing. It's the reason why DAP was created this way. Now I also understand another thing, which is why it's called a variables reference. I think in an earlier stream I had questioned that, like, why is it called variables reference? Shouldn't it be called variable reference because there's only one? But no, it's because it can be a reference to a set of multiple variables. So now that actually is clarified to me. It's all falling into place, and I see now what the goal is. I'm just not quite sure what the best approach for this is, because one thing is that at this moment I know what I need to know to expand this type, which is nice. It just feels like I'm going to have to store anyways a lot of information to be able to recreate it on the fly. And the whole idea of this one is I have a variable, create me the DAP type for it. So I have that. So maybe what I need to store then is a child reference that points back to the original variable. I think that's what I would need to do. And then when it gets expanded, I say, oh, this is a child type, and this was the variable. So then this code can exist somewhere else, I think. Yeah, something like that. Yeah, it's probably going to be that. Something like where when we create a dap variable for a given variable, if it's going to have a child, like I'm doing here, I don't create a variable for it and store it in this other thing. What I do instead is some kind of mapping of unique ID, like this here, to something that gives me back the original variable that is the parent variable. Let's call it that. There you go. I'm creating a child variable index, like a child variable identifier that points back to its parent. So then when we try to expand it, I can look at the parent and say, okay, this is an expansion of this parent. What do I do with it? And if that parent was an indirect type, I do this here. If it was a struct, I do this here. And yeah, that's going to make sense. So it's going to be, I don't know if it's going to be the same function or if it's going to probably be like two different functions. Yeah, that's what it has to be. Probably I'm going to have to just pass in like a bool or something that says whether or not this variable is the parent variable. So if it's false, it's pretty much creating the type for the variable and potentially adding an index for the child. If it's true, it means that that variable is itself the parent, and then I need to go and iterate over it and expand it. So maybe I'll split it into two functions rather than have it in the same. I think it might be cleaner that way. So it'll be something like, you know, create that variable, and the other one will be like that variables. Actually, this one would go back to only creating a single one at all times, and then the other one would be something like create child variables, and then I would give it a parent, and then that would split the two. I think that would make it clearer. So something like that. That may have children. For when expanding a top level. And of course, a child can also be itself a top level, but whatever. A parent, I suppose. Yeah, let's do that. Create that variable for parent variables that may have children, and create child that variables for when expanding a parent variable. The input variable ref is that of the parent, so that we can create the variable, the dap variable. Or its expansion. That variables for its expansion. And actually what I like about that is I think, well, yeah, there's going to be the problem of, yeah, there is a flaw here, which is that right now I'm creating a variable for let's say one expansion, but then for the next one, if I'm doing it this way, then I don't need to create these intermediate variables. Yeah, that's potentially a problem. Right. So maybe I will have to still create these dynamic variables just so that I can get them back. It doesn't make sense. It would mean that when expanding it, I'd have to create both a dap variable and one of my own variables. It doesn't really make a lot of sense, does it? Maybe. Maybe it does. I suppose it would make sense. My variables, my dynamically created variables, would act as the proxy to the dap variable. I'm not going to store dap variables myself. So yeah, and if I want to expand my own, I need to be able to keep that information. That's what bothers me about this, is that it feels like I shouldn't have a need for these dynamic variables, but I don't think I can get around it. So I will still need to give the count to dynamic variables, and we'll have to create one whenever creating a dap variable that has children. This way I can map a unique ID to this parent variable and pass that into create child dap variables. Okay, I'll stop here. I'll think a little bit more about this, maybe with a couple of days and a shower or two. This will all become clearer. And on Thursday, when I get back to this, we'll clean this up and make this work. Because I can totally like bang this out and hack it up, and I can get the structure to display, but it's definitely not the right solution. So I want to think of the right thing, and I want to make sure it's future proof. You know, it's got to work for all these types that are nested. So yeah. All right, guys. So I'm gonna stop it here. Thanks a lot for watching, and hopefully I'll see you on Thursday. All right, take it easy.